Let's turn that off. Let's turn that off. All right. Let's turn that off. All right. Let's turn that off. Uh, Hello everybody and welcome to the stream. My name is Nick Larson. It is October 4th, 2019. It's a Friday, so happy Friday, everybody. First things first, I would like to throw out a couple of shout outs for a few people that I missed at the end of the stream yesterday. Jason Punny, thank you so much for the follow. Sika Player, thank you so much for the follow. You might also notice down there, we have a new follow counter. We're calling them learners. Trying to come up with, some branding and whatnot. Um, and that's my introduction. So let's go ahead and get started. We are going to work on the same thing that we have been working on for the last 2 days. And today, what we're going to do is we're going to sort of look at things and decide, hey, is there anything interesting here? And that's what we're going to do. We're going to load all this up. I would like to say thank you again to Jason Punyon for helping me get all of this set up in a way that is enormously easier to work with. Let's go ahead and bring up the spec. Developer roles. Developer. There it is. Found it. Okay. So this is the document that we're working off of here from the standpoint of what we need to accomplish. And so we need to look at things like front-end developer, which has none. And what we need to do is find some tags that mean front-end developer. So we load up all this data. We're going to do this training. It's going to take... Oh, no. What do you mean training data is not found? Oh, wait. I got all these errors up here. Well, that's interesting. Model tags. Model tags. Training IDs. All data. Training ID. Oh. Model tags not found. Oh, training data. That's right. It's training samples. Because we changed the name of it. Oh, man, I screwed this up. I always screw this up. I never change the name of the stream before I start. Update. There we go. Okay, now we have model tags. Now let's do all of this. No more errors. Now we do the training and we wait, and this should not take very long at all. I don't know, maybe 2 minutes or so. And then we're going to take a look at it, and then what we're going to do is we're going to pull out the coefficients. We're going to look at the coefficients which have the most impact. And we're going to sort of see if they make sense. And if they do, then we'll just start filling in the values in that specification. And we'll do this time and time again. Excuse me. Ooh. Anyway, how are y'all doing today? There we go. That did not take too long. Let's take a look at it. Hey, same exact thing as yesterday. Okay, great. Model params, train. All right, now what I really want to do is get the coefficients out of it. Like, we're going to look at this stuff just because I want to click through it all. Oh. Oh, that's right. I don't have the final prediction anymore. I need test predictions. I think I'm just going to add final. Here we go. I'm going to do test predictions. And this needs to be greater than 0.5. There we go. Okay. All right, here's this graph we made yesterday. I don't really even like the geom text part of it, but we're just going to leave it anyway. It doesn't really matter. All right, now we're down here. Okay, so what we want to do now is we want to get the coefficients out of this model, and for that we're going to use a tool called Broom. Broom is a tool, library, Broom, for cleaning things up, that was written by Dave Robinson. And I believe the way that you do this is you literally just take the model, FE, and then you pass it into tidy. And there you go. Why is it 100 by 6? That's not making a whole lot of sense to me. Maybe it's more like coefs. Here we go. So these are the ones that it kept. Goodness me, how many are here? Let's store this in something. Okay. Model fe.coefs equals this. And then we can say model, just sort of want to view this. That didn't work out quite like I thought it was going to. Okay, so there's 880 features. And I think, I don't really know how to get this. X? Looks like it's X. So maybe now let's take tidy of model fe.coefs. That appears to be what I'm looking for. Okay, so let's take a look at the previous plot here, and we noticed that there was about 350-ish parameters in the model, and what we see is that it omitted 21 rows and it printed out 333. So it seems that whenever we just say give us the coefs, it's giving us the lambda 1sc coefs, which is fine. We're not going to worry about that. We're not going to try and like modify that at all. We're just gonna stick with it. Okay. Now what we should have is model fe.coefs, and now what we can see is that we have an intercept term, and then we have JavaScript. All right, here we go. All right, so now what we want to do is basically arrange these by their absolute value and see, well, really what we want to do is just arrange them descending and take a look at that. So model fe.coefs arrange descending value view. All right, now what we see is front end, front, com, Elm, W3C, hybrid, React.js, Compass, CSS3, Flex. All of these things are sort of making sense to me, right? Like what our job is right now is to predict what tags should automatically drop something into being a front-end developer. So that's sort of the goal here. It would be a little naive to just sort of do this all at once. Hey, what's up, Ganesh? How are you doing, man? Hope everything's good with you. Yeah, today we're doing a little bit of work here. My job is to take the tags, or to figure out which tags on job listings on Stack Overflow should represent which roles. And right now we're doing front-end developer. And we've gotten to the point of like training a model that is about 90% accurate on the training data, about 91% on the test data, which is awesome. And what we're doing is we basically took the coefficients, ordered them from like in descending order, and then we're taking a look at which which words or which tags it thinks correlate to meaning that the job is a front end job. And I feel like we've done a fairly good job here. We got front end, front, com, Elm, W3C, hybrid, React.js, Compass, CSS3, Flex, Gulp, Grunt, Sass. I don't know what VB doesn't sound right. Flux. I'm not sure what Flux is. Require.js, Vue.js. Yeah, all of these things, high charts, Bower, sure. All of these things to me definitely mean front end. So I feel pretty good about this. I think I probably would limit it to the ones that are just like the most obvious. See, and you got to skip a few. Even though the model says things like high charts is more important, I would probably stick to things like AngularJS, responsive, CSS. Probably not even Jade. Jade is more of like a language, I believe, like a on the back end, you're like how you spit out, how you format your HTML and whatnot. JavaScript, another one that I would probably not do. Oh, Flux is a React architecture pattern. That's cool. I did not know that, man. Thanks for that. User, no. And, well, that's interesting. So, yeah. I mean, overall, I feel like this did a pretty good job. I mean, a lot of these, Ember.js. We could just take this model as is and leave it in here and say like, all right, this is the whole model, and anytime we want to do this test, we would basically just run this model. I don't exactly want to do that at the moment though, because I need to talk to the PM about that, and I'm not gonna like invite him on the stream here like in the middle of a stream. But I will definitely talk to him and say, do we want a model that takes into account all of these? Interestingly, if we go all the way down to the bottom, you'll see that a bunch of them are negative. So if you see the tags sysadmin, you have a pretty good indication that this is not a front-end job. Same thing with QA, embedded, Android, DevOps, designer, more interesting. Full stack, okay, interesting also, but not. Product, definitely not. Symfony 3, iOS, graphic, Direct 3D, mobile, classic, wireframe, game, T-SQL. I feel pretty good that all of these are not front-end things. And the model here says that they should very strongly weight against it appearing to be. So I feel pretty good about this overall. And I think what I'm going to do is just take like maybe the top 10 or 15 ones that obviously stand out. Like MVVM is not limited to the front end. 3.js, sort of front end, more in the line of like games, I would say. Less, I would say, is definitely front end. Struts is a back end framework. So those sorts of things. HTML. But again, these things might also be really popular for front end and full stack. So these are things that we need to sort of weigh out, because the way that this thing is set up, you can really only have a tag lead to one or the other. So what I think I'm going to do here is take the top, like, say, 100 of these. Actually, I probably... Mocha, Karma, Sub, Hamel, Browser. I mean, Browser, that's definitely going to be front end. Maybe? Anyway, so again, the interesting part here, NA, that's also interesting. No tag makes you front end. I don't know. So what we want to do is, I'm just going to grab out the ones that are like most obvious here, and then we're gonna call it for those. Probably go down to like, I don't know, definitely less. Gonna take these. All right, Control H, Control D plus, Control Tab. Okay, replace all. Control H, Control Tab, comma, replace all. And there we go. These are the ones that we care about. All right, so this is going to be front end. And now we're just going to do this over and over for all 14 of our different model types. And how are we going to do that? We're going to look at job tag roles. Let's see, we have job tag roles. Distinct role. Oh, wait. Damn, no. What do we want to do here? I think we just want the names of, okay, all roles. Do I have an all roles? Because that would make this super simple. All labels. Yes, I do. I have an all labels. Okay, perfect. Let's do a row name of all labels. No, call names. There we go. And now what I want to do is basically set this up as a function that's going to run over and over and output a file for each one. So we're going to say function this is going to be called do modeling. Function takes in a model role, and then what we're going to do, I don't even care about plotting them. I don't even care about the accuracy. I literally just care about doing this. Like that. And then down here, spitting out the thing that we learned. Like that. So we're going to say coefs tidy, and then we're going to say write CSV, and the path is going to be paste 0 of, oh god, model underscore model role dot CSV. Is it collapse? Let's do a paste 0. Actually, let's just copy this since I already have it. And I think collapse equals true. No, collapse equals nothing. All right, that is exactly what we want. So what this is going to do is it's going to do the model, it's going to create the model, then it's going to get the coefficients out, clean them up, and write out that to a CSV. And actually, I don't even care about all of the coefficients. It has this thing called a column. I'm just going to select row. Let's do an old select tag equals row and coefficient equals value. And let's see how that works. Okay, that's perfect. That is exactly what I wanted it to do. Probably want to talk to Dave about that. I'm just going to Google this real fast to see if there is a known solution for whatever this is. Deprecated. Could you please turn this into a self-contained reprex? It's frustrating when all you see is, can you please turn this into something else, when the code is right here. Oh, I see. Well, Play Store Lasso certainly isn't there. Sure. Okay. Broom source. deprecated. It's frustrating when you see that something is deprecated but don't know how to fix it. Is that what this is? I don't really know. It's like it doesn't tell me what to use instead. Okay. I don't know. Not going to worry about it. Come back to it. Right now it doesn't seem to be a problem. It's just deprecated, not gone. Do you think the stream would be better with a little bit of background music? And secondly, is there a way for me to turn background music on without me having to hear it? I'm not sure if that's possible. Okay, so this is what we wanted to do. Then we're going to print this out. And I think at the end here we're going to return model FE in case you want to continue doing the rest of this down here. So now what we're going to do is we're going to say and then we're going to say model F. I don't want to do model FE. Let's just do model. There we go. And then we're going to have model FE equals do modeling of front end developer. All right, so this should write out a file. Oh crap. Nope, I need to stop this. Okay. I need to set this as my working directory. I need to go to datasets, dev role prediction, open this. I need to set this as my working directory. I need to copy this so that the next time I come in here and try to run this, it actually does what I want it to do. Okay. What are we doing? We are generating a model which should now spit out a file in here. And let's see how long it takes. All right, so I think conceptually what we want to do here is we want to generate all of the models, and then we want to load up all of the models. We want to put the coefficients for each of the models into a data frame. So what we have is like basically a column per tag, and I'm sorry, a column per model, and a row per tag. And then we'll take the maximum index of each of the tags and say if you're going to assign it to one of these, it needs to go to this one. And then we'll just go down the list until they all look good. Until we sort of assign all of the interesting stuff around. Okay, so it spit out a front-end developer.csv, And there we go. We got tag coefficient. All right, this is perfect. Probably want to go ahead and just arrange these for the sake of my own well-being. Arrange descending coefficient. All right, and now this is as simple as an if statement, or not an if statement, a for. Really? There might be a more interesting way to go about this, which would be to just capture these? I think so. Well, no, we need the model. Let's have a separate function for rate coefficients. Okay. And now we can say this, and then we can say rate coefficients model FE dot coefs equals rate coefficients of model FE. All right, and this is what we want to do essentially in a for loop. Now, it's been a long time since I've written a for loop in R, so we're going to go ahead and take a look at how to do that again. Write for loop in R. How to write the first for loop in R. Feel like I clicked on that? Data Mentor loads much faster. Okay, for something in something, do something. Sure. For model role in, or for role in row names of, no, call names of all labels. Hey, CM Griffin, thanks so much for the raid, man. I really appreciate that. How are you doing today? I checked out your stream for just a few minutes there. I love your collection of keyboards in the back, man. I'm doing great. I say I'm doing great. It's been a stressful week, but it's fucking Friday, so I'm doing good. I am doing good. I am actually doing good. Yeah. No, but yeah, I really hope you had a good day, man. I hope everybody was productive and doing whatever it is you wanted them to do, because it's your stream, your role. Hey, Oblivioner, how are you? This is R Studio. Right now I'm writing some R code to do some predictive modeling for if a job comes into the job board on my website, can I predict what role, like what job role is it for? Is it for like a front-end developer, a DevOps developer, a machine learning developer, just from the tags alone. And that's sort of going in reverse here, because the actual goal is if I know that it is a like, if I know that it's like a DevOps role, what tags would indicate that? So I'm trying to identify which tags are the most likely to indicate that this is a DevOps role. And I have to do that for, I don't know, maybe 10 or 15 different roles. All of the ones that don't have tags right now, I have to do that for these. So the way that I'm going about it is I took all of the jobs that we have and I said, yep, I have to run to a meeting in a moment, but have a great one. Thanks, man. Have a good one. And hi, Rossetti. How are you doing? I just saw that one. Thank you. Yeah, so the way that I'm going about this is I'm basically building a model for each one of these. Hey, thank you so much for the follow. I really appreciate that. Building a model for each one of these, and then getting the weights of the coefficients, and then basically I can only assign a single tag, or I can only assign any given tag to one particular role. So if I find that a tag is really strongly weighted for one particular role, then I will assign it to that. But if it can be tossed back and forth between two, then I just won't assign it to either because I don't want it to be confusing. I don't want it to screw it up. That sort of a thing. And so what I'm doing right now is writing a little script that will build a model for each one of my different labels. And I think there's like 14 or 15 of them. And once I have all of those done, then we're going to build up a giant like matrix data set, data table, data frame, whatever you want to call it. And we're gonna basically look over it by hand and see if we can figure out by hand if what tags should belong to what thing. And that's pretty much it. That's what we're going to do. There's like 800 tags, so it might take a hot minute. Maybe we won't end up doing it by hand. Maybe we'll figure out some more interesting way, but right now that's the plan. There's a lot of them that I think we can just kind of ignore like outright, so I'm not going to worry about those. And right now we're just forcing this to actually write out each of the models. So it's going to basically create the model, then it's going to take the model, extract the coefficients, and write all of the coefficients to a CSV. As someone trying to get into this space, any recommendations where to start, as in PDFs or books? I would say, answer a couple of questions for me first, and then I will guide you almost certainly in a workable direction. And the first thing is like, what kinds of problems are you interested? Like, what sorts of problems do you want to solve? I have no clue about R, but we had some Prolog in high school some long time ago. Prolog. It's been a hot minute since I have seen any Prolog, and I don't think I have ever written it. What did you use Prolog for? That's interesting. All right. Okay. Prolog. Is Prolog one of the languages that has a... Now I have to look it up. I'm sorry, you got me. You got me. I have to look it up. Prolog syntax. Prolog syntax. A concise introduction to syntax. Oh, in BNF notation, no less. I can't read this. Can I just get some examples? Parent, Jane, Bill. Okay. Example, mother, absolute value. Goodness. Okay. Working with data from drones and images captured from them. That sounds amazing. What exactly do you want to do with them? So when you're dealing with images, you have a very dense data set. It's not sparse like text is, right? To explain what I mean there, on these jobs, the jobs look like this. So if we go to Stack Overflow / jobs, right? You can see that this job has, I don't know, 5 tags, but there's about 14 or 15,000 total tags, and any job only has 5 of them. So that's what we would consider to be a very sparse data set. Whereas with images, usually each pixel has a value in whatever size image you're looking at. And so you use totally different methods to compare these sorts of things, or to work with these sorts of things. All right, basically comparing one good image versus a new image and comparing them. So you'd have to give me a definition for what you mean by good in terms of the problem that you're trying to solve. Are you trying to identify objects that are in it, and if you identify the correct object, that is what's considered to be good? Like, what is the actual problem that it is that you would like to get into? Like, there are lots of drone images out there. I think even Google Maps is filled with drone images. Maps.google.com. Right? If you go to satellite, no, that's a satellite view, but they have other views. Which one is it? Imagery? Nope. feel like, no, I don't know. I feel like at some level they had set it up in here where you could get like a sideways view. All right, so we're taking images of an object. DES, thank you so much for the follow. I really appreciate that. So we're taking images of an object and using the images to find potential issues with said object using a cluster of drones. That sounds awesome. That sounds really awesome. Okay, so in this case, I'm not working on it. I'm a DevOps engineer, and I was to help the ML guys. So that's funny. That's my actual job. I am a data engineer. So I don't really do the ML a whole lot. Oh, you want to help the ML guys. Okay. So it sounds sort of like what you're looking for is some sort of, what would be the right term, is outlier, looking for anomaly detection, right? I don't know exactly like what the object is that you're looking at with these drones, but you have some baseline that says that this thing is in good working shape, and if you identify something, then you want it to raise some sort of flag and say, oh nope, there's a problem here, we need to look further at this, maybe have somebody go out. It's funny, I've heard of a case almost exactly like this where there's a guy whose responsibility it was to like go out into farm fields and inspect the giant, like, you know, when you fly over and you see the giant like crop circles on the ground. The reason they come up in circles is because there's a giant arm that like rotates on a circle, and it's like a huge sprinkler system. And the guy's job was to go out and like look at all of the different links and connections and make sure all of it was in working order. And I remember hearing a conversation about how he ended up using drones to do something very much like what you're talking about. Instead of him having to like get out there and manually inspect this thing, the drones were trained to fly around these things. And even better than that, the drones could fly around them while they were working. So they no longer had to shut these things down in order to inspect them. And then when they noticed some sort of problem or some sort of anomaly, yeah, the guy would actually go out there and they would fix whatever the problem was, or, you know, inspect it a little bit more, whatever. Okay, cool. Yeah, so for something like that, you know, really what you want to do is get yourself a baseline of images that represent the problem that you're looking for. And then you want to get yourself a baseline of images that represent, you know, the good working condition of a thing. That you could, at the very least, you need images of the good working condition. Too many sheep on field. Execute sheep. Well, I'm not an ML guy, so where should I start? Lots of places. Okay. The first thing I would say to do is not worry about the ML side of it and just think about how you would do it as a human here, right? Just to get yourself like conceptually in the right mindset. Okay? When you're looking at something, what is it that you're looking for? Is it a color disfiguration? Is it a shape disfiguration? These sorts of things, because whatever it is, you'll end up using different methods to identify each of those, right? If it's color, you don't even need ML. All you need to do is like, you know, figure out how to detect differences in color, which isn't particularly difficult. The only issue you have to worry about there is like, you know, does lighting affect the color? If the clouds are out, does that matter? Is this in a controlled environment? All of these sorts of things are the things that you need to think about when you're designing the system that goes into it. So think abstract before learning ML. Yeah, I mean, like, this is why it matters when you're talking, this is why I'm asking about a problem, right? If you know the problem and the details of the problem, it will actually guide what sorts of algorithms and what sorts of techniques you end up using, much more so than just like, if I know ML, can I apply it to this? The answer to that is always yes. I mean, if you've got a hammer, you can build a house. I mean, it won't stay together for very long, but you can do it. And if you instead have the right tools, you use screws where you should use screws, you use nails where you should use nails, you use rivets where you should use rivets, like your house will be much stronger. If you put the pieces of wood in the correct configuration, the frame will be stronger. You know, it's these sorts of things where it's like, if you just understand the problem, then you can address the issues that are specific to the problem. So yeah, don't beat yourself up about it or anything like that. It's just more of like a mindset thing about like, okay, when you come to me and you ask me for help and I'm like, how do I get from here to Chicago, right? You probably don't even know where I live, except for the fact that you're looking almost exactly at it right now because that's where it's at when I went to Google Maps. Um, but yeah, it's like there are a lot of ways to get to Chicago, right? It's, do you want to ride a bike? How long do you have? Are you afraid of flying? Are you afraid of trains? Have you ever been in like a horrific wreck before? So many different factors that go into it that would decide the way that you're actually going to end up getting there. And you just want to ask and be able to like inspect the details of the problem to really understand like what the constraints are, and then we start actually going towards a solution. It is very nice though to have some background in ML. I don't want to tell you not to learn it or anything like that. Go ahead and go learn some algorithms. Figure out how to use a neural network. Figure out how to put together nearest neighbors. K-means. Like there's a bunch of like really foundational algorithms that you can learn, and then all of a sudden when you start looking at problems, and you'll start thinking to yourself exactly like, oh, I have a hammer, can I apply it to this problem? And the answer is almost always yes. Can you solve the problem that you want using k-means? Absolutely. Can you solve it using I don't know, logistic regression? Absolutely. Can you solve it using a neural network? Almost certainly, right? And it's like, why would you choose a different one? That's what learning all the algorithms, helps you discern between. When should I use that rivet? When should I use that nail? When should I use, the screws? That's the sort of stuff you learn by just kind of applying all of these different techniques to different problems and just getting comfortable with it. And no, I really appreciate you asking that question. It was a really good question. And yeah, like I said, I hope this was helpful. This stream here is all about mentorship and all about learning. So yeah, keep the questions coming. I'll be more than happy to answer. In the meantime, I am going to run this thing and see if it breaks or not, because like everything breaks the first time I run it. So if this is successful, you should just start seeing files pop up over here, right in this area, in a moment or so. I should probably have put like something that prints out so we know how far into it is. I think it takes maybe 30 seconds or 45 seconds per model. Not really sure. And then yeah, like I said, we're just gonna connect them all together. But yeah, I would say definitely like learn the foundational stuff first. If you want to jump right into something like unbelievable, you can get into deep learning and you will never learn anything else because there's so much to learn about deep learning. You could spend your entire life learning it. And it's moving so fast that by the time you felt comfortable with it, you would already be on to moving some, the entire technique will have moved on far beyond where you are now. Right. I would say like it's not hard to get a hold of data. I really expected something to print out by now. Oh, I just ran freaking front-end developer. See, there's always a bug roll. When you call the same function over and over with the same parameters, you should expect the same output repeatedly. So now I'm going to have it be print roll. All right, we're going to do front-end developer first, then we're going to do the other ones. So yeah, practical cases. I would say choose a very well-studied problem, because when you want to go look up and get help about it, there's going to be shitloads of it out there, right? When I was in college, the problem that I carried with me the entire time is the handwritten digit recognition problem. And there is a data set for this one called the MNIST data set, right? And basically, I can't even show them to you. So basically, this is a data set, and all the data set is images, very small, compact images of handwritten digits. And the problem is you have to identify the handwritten digits. And to say like, okay, this is a 1 or this is a 2. In fact, maybe a better way to go about this would be to do MNIST and then just go to images. Here you go. So these are what they look like. And let me zoom in on this so you can actually see. Can you see that? All right, this is what they look like, right? You can see that nobody writes digits the same. And this data set is something like 60,000 people wrote the digits 0 through 9. Okay? And your goal is, given any individual image, to predict what number it is. And you can see that some of them are really crappy, right? Like, it's really hard to tell whether this is an 8 or whether it's something else. It's really hard to tell whether this is like a 4. Is that a 4 or is that a 9? And it's these sorts of like little quirky things about the way that people write their digits, and you need to be able to tell correctly what the answer is. Right? And then it just turns out that all you do is you just start applying technique after technique after technique. And you can get really, really close with a lot of them. Even back in the day when this data set was introduced, I want to say it was introduced in 98. And in 1998, they got to a test error rate of only 1.1%. And this problem actually turns out to be quite interesting because the person who invented this is also the person who made it so that you can take a check, like somebody gives you a check and insert it into an ATM, and then it reads the check, right? It looks in certain places on the check and it says, okay, this looks like it's an account number, this looks like it's a routing number, this looks like it's an amount. And it's solving like a real problem, right? And you can see this one uses a linear classifier, one layer neural network, which is effectively just I don't know if it's a logistic regression or if they're just using it is a classifier. So yeah, this is a logistic regression with a multi-class output. Then k-nearest neighbors is a really, really, really simple algorithm where you basically, in your training set, you just put a database of all of the data, and then when you get a new sample, you compare it to each and every single thing in the database, and you measure the distance away from it that it is. The distance, I put distance in quotes here because there's a lot of ways to... Yes, that's right. Like when you scan it on your phone to take a deposit, it is the exact same technology. That's exactly what this problem is for. And so, yeah, k-nearest neighbors is like a totally different method where you're just comparing it to everything that you have ever seen before and then deciding which one it looks most like. And there's a lot of different techniques for deciding, what closeness means. And you can get into all of that. And then, boosted stumps. A stump is a one-layer decision tree. And boosted stumps is a bunch of these individual decisions, and you weight each one more and more and more as you get further down the line. There's just lots and lots and lots of different techniques, right, for solving the exact same problem. And if you go through here, I mean, literally hundreds of papers. And if you go and research on some place like scholar.google.com and you search for MNIST, right, there are 30,000 results, right? Like, you will find an enormous amount of information. So no matter what technique it is that you want to apply to this problem, somebody has probably done it before, and you can get a good idea about whether or not you're doing an okay job just by comparing your results to other people's results, right? Am I implementing this correctly, et cetera, et cetera. And that would be another thing I want to talk about. Since we're on this topic, there's no reason to write your own code that does all of the math, right? Unless you're just like totally into that, you don't need to do that. All you need to do is go out there and download some code that does it and then just pump all the data in. Like, that's your job. Thank you so much for the follow, V Whiskey. I really appreciate that. Happy Friday to you. Yeah, like, don't waste your time with writing all of that stuff unless it's just like the thing that you're just like totally into. You'll notice right here, like, what did I do? I called a function called cv.glmnet, and I told it to run a logistic regression. That's what I did. I told it to use, cross-validation using 10 folds. If you're not sure what that is, you know, you can get into that. But the idea here is that it's basically doing some averaging of multiple models to make sure that the test results are going to be more accurate than just doing it one time. And it's like, I didn't need to write all the code to run it 10 times or anything like that. All I needed to do was call a function and just say, go do this thing. And then when it goes and does that thing, it gives me back something that I can more or less trust, right? There are some times when you actually do have to go and write the functions, but you'll see, like, sometimes it's ridiculously easy. All right, let's talk about the model that actually gets spit out of here is what's called a logistic regression. And a logistic regression is literally an array of numbers. Okay, like the model itself is an array of numbers, and each of these numbers represents a feature. In my case, they represent tags that are on questions. Well, I mean the same with writing programs. You aren't going to write system.print every time. Absolutely not, yeah. There's no reason to. Of course. I am all about pulling in whatever code it is, you know, given the constraints of your company, making sure that it passes all of the legal and security requirements, et cetera, et cetera. But yeah, like pull in as much as you possibly can. If the whole write it yourself all the time thing, I think gets really old really fast. And then I sort of expected all of these to start dumping out in here. Like, did I screw this up? Model. Oh, crap. There is no model role. See, I screwed it up again. Damn it. This is stupid. Okay, I have to kill it again. I never write anything perfect on the first try, and apparently not the second try either. Okay. Write k-means and SVMs yourself and MATLAB was literally my uni ML course. Well, k-means isn't that bad. I don't know about MATLAB, but certainly in like languages like Python, it's not that awful. And I think when I did it, I actually wrote it in C#. It wasn't that bad either. Just depends how fast you need it to be. If you need like an efficient implementation, I don't think I could write an efficient implementation depending on your data. Where did you go to university? It's awful and slow and compulsory for me, yeah. So one of the guys that I graduated with went to go work for MATLAB. Oh, I should put that in context. I graduated from grad school in May, so very, very, very recently. Yeah, welcome to development. Okay, if this time okay, I saw the size change, so I'm gonna guess it's gonna work this time. I'm gonna put a little counter up here that's like number of times I had to try to get this thing to work. Maybe up here in the corner, down here. Number of times I had to Google today. There, no, still going. Anyway, yeah, what do y'all do? Yay, it spit out a new one. All right. When this gets done, we're going to have a bunch of files. I'm going to put a break down here looking at the accuracy and success metrics of the modeling. And right here I want to put something along the lines of deciding which tags should go to which roles. I'm lucky and had good mentors and didn't have to go to college. Now I want to go back and get a better understanding of foundations. Go back to college. But principal DevOps engineer at Fortune 100 company. Nice. That's awesome. Yeah, DevOps is something that like I feel like I should learn and just haven't. There's nothing really stopping me. 25 years. That's awesome. That's a good long time to stay in it, man. Congratulations. Or okay. Do you ever work with time series data? Occasionally. Um, the right way to say this is almost all data is time series data. So, in a sense, yes. Very explicitly modeling things as time series data, I have only done a couple of times. And the times that I did it were around advertising, and I hated myself for doing it, but it did turn out to be successful. We applied TD learning to basically deciding which ad to show you in a series. So, like, if we show you this one first, and then we show you this one, and then we show you this one. So, TD learning is a type of reinforcement learning that basically means, I'm almost certain the T in TD stands for time differential. No, temporal difference learning. So, temporal as in time difference learning. And it means that, like, you see one thing, and then you see the next thing, and then you see the next thing, and it's the chain of events that lead to whatever the success is at the end. And so we said, if we show you this kind of ad, and then this kind of ad, and then this kind of ad, how likely do you now become to, click on the fourth ad in the chain or something like that? Yeah, no, not quite. So there's like three different kinds of temporal difference learning. There's like TD0, TD1, and TD lambda, and they're all like TD lambda is just a mix of TD0 and TD1. So TD1 says the only thing that matters is the exact state that you came from before this. TD0 says it depends evenly on the entire history of things that came before this. And TD lambda says the things that are most recent are more important, and as you go back in time, the importance of previous samples really trails off. And those are the three different models that you get out of it. The math for it is like ridiculously easy. Actually implementing it turned out to be quite a bit harder. But yeah, you should check it out. It was written, I want to say it was Dr. Sutton came up with all of that stuff. Where is he from? Somewhere in the Northeast, I think. It sounds like gradual relaxations on the Markov assumption. Almost exactly. Yeah, that is almost exactly it. But the Markov assumption is that just the single state before matters. Or I guess that's the Markov principle. And in a sense, you can, hand wavy, you can treat all of the things exactly like that. Yeah, exactly. There you go. Sutton 88 with erratum. That's right. And I believe the book is called Incomplete Ideas. You should just read the whole book. The whole book is great if you have the time and the patience. But yeah, each of the chapters is actually quite independent from the others. So even if you don't have to read the whole book from start to finish to understand it or anything like that, you can read just the chapter on TD learning, and as long as you understand it, you'll understand it. But yeah, the hand wavy thing about the Markov assumption, of course, is you can just sort of roll up all the previous states into the current state, and the math works out the same. Okay. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, Funky Monk 420, thanks so much for the follow. I really appreciate it. Thanks for hanging out. Also, thanks for finding that paper. Do y'all read papers, by the way? Let's go ahead and pull this up. If you've never read a technical paper before, let's just look at that real fast. I read white papers all day. Okay. Oh man, it's one of these ones where they scanned it in. Makes it kind of difficult to read. I think I actually have the book. Maybe not here. Maybe it's in my room. But yeah, you get into it, and then it was single step computational issues, equations. Yeah, one of the things that made me a much better software developer was like looking at something like this and writing it, like literally writing the code that does this. Now, of course, you can't just do that like outright. You got to understand a little bit, but I mean, this is a sum. It's literally a for statement. This is looking back in an array at something else. This is a difference of two different values that you're multiplying times that, and multiplying times this thing that you look up in some other array. And that is literally how you do stuff like this. And then you take the whole sum and you multiply it times whatever this alpha means, and it's just a subtraction of whatever the current state is minus the previous state. No, wait. Yeah, this is the part where you got to understand it a little bit. I'm going for my master's in data science right now. I've been reading a lot of papers. Oh, that's awesome. Where at? I just took the Georgia Tech online program. One of my weakest points is math. Me too. It just is what it is. University of the Pacific in San Francisco. That's awesome. Congratulations, and I hope you stick with it and all of that. I wanted to quit like 3 times. Like, there's only 10 classes in the whole thing. I took it in 3 years, and I wanted to quit 3 times in 3 years. If it wasn't for my wife making me go and telling me that I was going to need this in the long term, I would have quit. It was way a lot of work. Examples of faster learning with TD models. A game playing. Oh yeah, this right here. You should implement this one. Okay, if you do read this, you should implement this game right here. Expand. I'm on my last year, and I think I'm through the toughest part. That's awesome. That is super awesome. Yeah, my last semester I took a class on computer networking, which might as well have been titled How the Internet Works. Pacific Northwest, flunked out of college for network tech, joined the IT help desk. Now I'm level 3 and studying code, University of Udemy. Oh, that's awesome. Also, thank you for the follow. I really appreciate that. Man, I love networking too. I did not know anything about it before I took that class, and it really lit a fire under me. Like, it is so fun. You can do so much with it. And it's like crazy how just like literally duct taped together it is. A random walk. Anyway. Okay, is this thing done? There were 28 warnings. I don't care. Now what we want to do is we want to load all of these up, and we want to combine all of them into... And we want to combine them into one whole thing. Okay? So I think I want to do something, and this is the part of R that I'm the worst at, where I want to basically tell it to load a bunch of files. We're going to do something like, yeah, BGP. It's amazing that my video is still getting to you. What do I want to do here? I want to read CSV is definitely the thing that I want to do. And I want to do an apply And we're going to have to look up the apply as sort of like a for statement in a sense. And what I want to do is say call names of all labels. And we're going to write a function called getData, getCSV coefs equals function role. And then we're going to do this thing right here. I'm going to call this model role just to be consistent. I'm going to say reads CSV of model role, and I think that's it. And we're going to do lapply, meaning list apply. So there's a bunch of different versions of apply. Apply you could think of as like a for loop in R. If you just use apply, it sort of delegates to one of the other versions. And the other versions are like lapply, or sapply, or mapply. And yeah, here they are. Okay, so lapply, sapply, vapply, replicate, simplify to array, right? And in this case, what you're determining is the return type, and the L means I want you to return me back a list. In R, pretty much everything is a list, and it's you would most. So I am going to break your understanding of this if you actually do understand R, but you should think of a list as like a JavaScript object in a sense. It has a name, and the data type within that name can be anything, and you can have as many names as you want. It's basically a hash. They just call it a list. That is the best I can possibly tell you. Unfortunately, the way that you reference things is not with a dot. Like in this language, you wouldn't say things like, model dot something. That is a single variable. Okay, a dot is just like any other character. If you want to say what would be a dot in like, any C-based language or Java or whatever, you instead use a $sign. And a $sign is the thing that actually gets you to the value within model that has the name something. And now the problem becomes when you start getting deeper and deeper into it, it's difficult to understand. And I can't really explain it that well, so I'm going to stop. Yeah, sort of like PHP. But the issue is that like everything is an array. If you ever see a single value, something like 45, that's an array. You see how it has that 1 right there? That's because that is an array. There is no such thing as just a singular value in R. Even if you were to say like 45 and then index it with 1, you get another array back. So you can't get out of the array zone in R, and it just makes it really, really complicated to keep following along. At least for me, it just is past me. It makes sense until you get into this situation where you're like model $sign something and then $sign something, or let's just do $sign ABC, $sign DEF. All right. It doesn't matter that you referenced ABC directly and then you referenced DEF. DEF is not contained within ABC alone. If there is any other property on the model that also has a DEF, so like if there is down here a model $sign, XYZ and then also DEF, and you do either one of these, you will get back the values for both of them. And it's ridiculous. It doesn't make sense. And if you want to do things like load in some JSON that is not in a flat format, oh, what a nightmare that turns into. Like, that's the part where I struggle the most. Yeah, it's like really, really ridiculous. You also have no idea which one came from where. So when you call this DEF and you get two values back, you don't know if it came from here or if it came from here. You just know that it was in there. Okay. So we're going to read in the CSV and we're going to lapply it. We're going to read it in as a list. And this is get CSV coefs. And now we want to say data, or data is a bad name. We're going to say all coefs equals this, and we're gonna work on this as best we possibly can. Okay, so now to show you what this looks like, we have all coefs, and it's a list of 14, right? But what we did not get back was the names. We didn't get back the names. That's awesome. That's great. All right, thank you for joining. I hope you have a good day. Let's see here. We have all coefs. Let's just do names. Null. Row names. Okay, so we have 1 through 14, and what we really want to do is get names back, because we need to know which file they came from. So that's the thing that we need to do. I tell you what we're going to do. We're going to read a CSV, and then we're going to add in a column that represents the model. Oh, nice. I work from home as well. Working remote is it. So we're going to add a column, mutate, model equals, or role equals model role. And then I believe, all right, now we have the role in each one of them. Now what we want to do is combine all of these into a single one. So I think you do something called do.call, and we're going to look at that. Again, do.call is just a single function name because a dot is just like any other letter. Do.call what args. Either a function or a non-empty character string. So we're going to do do.call of rbind. What do we get back? Hey, all right, all right. See, there we go. Okay, now what we want to do is we want to basically say for each one of the tags, let's filter out all of the coefficients that are lower than a set amount. Okay? So we're going to say all coefs filter. Can y'all see that down there? No, you can't. Let me see if I can fix that for you. Now you can see what I'm typing. Mostly. Okay, so filter is just like, well, exactly what it says. It's a filter. And we're going to say coefficient is greater than, I don't know, 0.2. Right, that would be the, or maybe even 0.5. That would be the minimum we would take. Maybe not. See, they're all scaled differently because they have different intercepts. Let's just say 0.2. It's got to be positive and not trivially positive. So we're going to say all coefs, filter this, and then we're going to say arrange. And we're going to say first thing we want to do is arrange them by tag. Then we want to arrange them by coefficient descending. So minus coefficient. And then we want to view them. So by doing it by tag first, we get to look at each and every tag. $11. I'm going to guess that that's not actually useful. And then we have, how many of these do we have? That's such a great question. We have 1,400 entries total. Yeah, it's not that bad actually. All right, 14.2, we can ignore all of these. All of the numbers we can just outright ignore. Access is a data scientist. That is super interesting. I mean, to me that doesn't make sense, so I'm not going to do anything with it. ActionScript as a mobile developer or a game developer. It certainly seems like that makes you a game developer. Does anybody here know what ActionScript is? Isn't that the Flash thing? Yeah, okay. I think it is gonna die. I think just yesterday I saw something where Chrome is gonna just like eliminate Flash completely. It's pretty much JavaScript, right? Yeah, I don't know. I think I'm just going to ignore that one. You know, one thing that we could do here is we could basically just group these. And the ones where there is more than one, we can just sort of throw away. So you have system administrator and database administrator. The only way to know this is if there are two tags. Let's just make a note of these. Okay, Control A. Admin, administration, administrator. These are the ones that I want to go back and look at later. Adobe definitely makes you a designer. Let's see if they have that one. Designer. I'm going to go ahead and add Adobe. Okay, so now I just want to make sure that we are in suggesting mode. Adobe. And then AEM, front end or back end. Agile. Nope. Air. Mobile developer, desktop developer. I am curious about that one. Air. Let's go to Stack Overflow. Let's go to air. What if I just search for air? Tech? Air. Literally air. How come this doesn't have it? I was really hoping this was going to have it. Search. This isn't exactly what you search for, but you might be interested in these. Air. I don't know. Whatever. Apply filters. Can I say something like jobs, tags to roles? Oh, wait. It would be in training. Air? Greater than 0. Are any of these true? Oh, goodness me, there are certainly ones there. Okay, so what I'm really trying to do is just identify one job that has air on it. And the way that we're going to do that is we're going to say tibble of training data. No. All columns must be a 1D or 2D objects. I feel like they are. Here we go. Tibble df. Nope. Okay. Control F. Does anybody see a true? I'm not seeing it. I didn't see it. But we're going to do it like this. Omitted 61,000 entries. Well, maybe that's the reason. Let's do match of call names of training data, and I'm looking for, wait, I think it's air. It's 851. Okay, so now what I want to do is say training data, and then I want to say training data comma air, training data comma air greater than 0. There we go. Found them. So these are job IDs that have air in them. And it seems to think that air was important. This job is no longer accepting applications. It does have air in there. What the hell does air mean? Oh, Adobe Air. Ah, got it. Okay. Junior Flash Client Developer, mobile. Well, alright. Okay, that was interesting. Reopen, close tab. No. Can't can't do that for me, can you? Flash developers still exist. Okay. Well, we found the thing that we cared about, and now we decided that we don't care about it, even though it was a really strong indication of a mobile developer. You know, the other problem here is maybe going with tags that are used as few as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times is just a bad idea considering there's 60,000 jobs. Like, there's no point in having that actually be there. I wonder, okay, so let's do this. Let's filter this even more. What we're going to do is we're going to say I only care about tags which are used at least 50 times across all jobs. So let's go and say call sums of all data. No. Of training. I think it is all data. Yeah, all data. Call sums of all data. And then what I want to do is say I think it's uh tag equals call names of all data and jobs or count equals call sums of all data. Okay. And then I want to filter this. Filter to say that count is greater than or equal to 50. And then I want to pull tag. And I want to say this is whatever. No, that's a bad name. I want to say this is auto tags. So what this is going to end up being used for is to auto tag. All right, and then I want to say filter tag in auto tags and then view it. Hey, there we go. All right, that took us down from 1400 to 875. All right, so now we ignore all of these. I feel like action script. Okay, Adobe means designer. We already put that one in there. Active means desktop developer. I am going to look for this one. Stack Overflow / jobs tech active. Oh man, this is awful. I just want to search by tag. Active as an active desktop, ActiveX. I'm not sure. I honestly don't know. Like that's why I'm trying to look it up right now, is because I just don't know. And I really don't want to go through that whole process again to figure out which ones active are, but I feel like we're gonna have to. Active. Give me one of these. It looks like they're all old. That's one thing that I noticed, because the IDs are not very high. Oh no, actually I take that back. Here's some high IDs. The IDs go up to about 158,000, which means that that would be something that was posted like yesterday, and this is something that was posted. You know, these older ones, 28,000. That was a very long time ago, like years ago. Okay, so oh, that's a problem. Ooh. Okay, so the problem here is it thinks that this job has a tag active, but the real tag is Active Directory, which means that whenever it is splitting out, it is splitting the tokens based on dashes. Which means that this step right here, unnest tokens, is problematic. How else can we do this? That's a good question. Man, that sucks. Because that means I gotta rerun everything. And let's just verify that before I rerun everything. Let's just do the old... we're going to want a string detect on call names of all data. And we're looking for a regex of dash. Oh man, please give me a mean that is not 0. Ah. It's a good question. I don't know if it has tokenizing options. Unnest tokens. Input token words. Okay. What are my other options? Character shingles, engrams, skipgrams, sentences, line, paragraphs, regex. Ooh, regex. We can do a regex. Format. 2 lower. Drop. Collapse. Table. Output. I don't understand this. Output. Okay. Oh yeah, the name that you want to output it to, the input token is regex. If a function should take a character vector and return a list of character vectors of the same length. Let's do a string split. So if I just put the token as string split, we should be fine. String split. Argument pattern is missing with no default. Okay, sure. Let's do... How do I want to do this? What if I just put a space? No. Could the regex even fix those other ambiguous tokens you had, like administrator, administration? I don't know the answer to that, but I'm going to guess that a very large part of the answer is yes. string split. Now, tokenize string split. What if we tokenize by word that preserves usernames, hashtags, and URLs? Well, that's kind of lame. What if unit for tokenizing built-in options are words, characters, character shingles, ingrams, skipgrams, sentences, lines, paragraphs, regex. If a function should take a... All right, we're just going to do this as like this. We're just going to say token... No, we're going to say tag split equals function tags. And we're going to say string split of tags and a space. Yeah, that's my guess. Tag split. Token equals tag split. Come on, one time. Okay, all right. All data, call names. Call names of all data. Let's do Tibble. Tags equals call names of all data. Filter string detect dash. What is the string? Tags. Tag? I should call it tag. Okay. Alright, that fixes that. But yes, we do have to rerun freaking everything. That's not what I wanted to do. Okay. One more time with feeling. Run that. Run that. No, I don't actually want to do that. I want this one to be... Actually, that is... Nope, I take it back. I do want that to happen. Do that, do that, do that, do that, do that, do that, that. Alright, this one's going to take a minute. Y'all ready? Okay. In all likelihood, by the time this finishes, I am going to run out of time because I have a call today that I can't miss at 2 o'clock. So I think I'm going to start winding things down, but since I've got 20 minutes, if y'all have anything you want to talk about, anything you want to ask about, I would be more than happy to answer your questions. You can consider this either like a mentorship period or just like a bullshitting period. I'm totally happy to do either one. Just, let me know what you want to talk about. I'm going to sit here and who knows, maybe it'll go faster. There should be fewer tokens now that it actually did this correctly. And lurking's fine too. I have no problem. Yeah, basically. Wait, what are you doing? Don't you have the day off? What are you doing on here, Nick Craver? The other Nick? It's relaxing. Fair enough. I do the same thing. I was watching these all last night in bed. What are you doing this weekend? Yeah, I practice that. It's the water. You drink 90 ounces of water in a single 2-hour episode, and your voice comes out nice and clean and crisp the whole time. I saw your tweet, by the way, where I was sitting on Jason's shoulder. I thought that was hilarious. Oh yeah, that's right. This is the one where... Wait, hold on. Is it Perf that you were writing about? What is What is the talk that you were asking us about the other week? Performance as a feature. Oh yeah, right. Simplicity as a feature. I like all of those, except Many Profiler. I don't know the people who wrote those, but man, they should fix it. It's got problems. Which conference is that? All things open. That's cool. Yeah, I guess I can still get some work done here. We're just gonna guess whether or not these were single or not single. So agile. You know what? For agile, I am gonna go ahead and guess that that is not a product manager because clearly it's on full stack developer as well. Ajax. Is there really Ajax for mobile developers? Is that a thing? Agile definitely applies to PM. I know, right? But the point here is that unfortunately, the way that this tool is set up is that each tag can only point to one of these. And so if it happens to see agile and like assigns it to QA, or like if I say it, if I say if it sees agile, then it needs to go to product manager. And it happens to be agile and it should have been a QA test developer, like that's a fairly large mistake. Like that's the difference between like a developer and a not developer. Hey, what's up, Secret Player? How you doing? Ideally, what we would like to do is just so I grabbed all of these from models. If we could just run these models and then whichever one gets the highest score, we assign it to that one. I would be all about that, but it doesn't seem like that's the way that this thing is going to end up happening. At least not in the short term. ACA. ACA is for backend developers. I'll take it. ACA, comma. Isn't that like data pipeline stuff? ACA. Build concurrent, distributed, and resilient. Oh shit, I clicked on it before I read it. Yeah, it seems like it's back-endy. Okay. Algorithm. Definitely data scientist. Not even a question. Even though it shows up on all of them, definitely data scientist. Amazon. DevOps. I'll believe that. I will definitely believe that. Probably backend as well, but I think DevOps is better here. Oh, this is one of those ones where it's like it's definitely going to end up being Amazon something. It's going to be like Amazon AWS. This is one of the ones that definitely got affected by having that dash in there. So I'm going to skip that one. Analysis, data scientist, absolutely. Data scientist. Analysis. Analytics, that one was already on there. Android, mobile developer, I'm going to guess that one's already on there. Oh, just kidding. Damn. Wow. Really? I'm gonna feel like that one was a mistake. Surface phone developer. Oh, wait, no, wait. There was a Oh no, we don't have it in here anymore. There was at one point a Windows Phone developer, and like we just literally don't have enough data to build a model for it. Angular front end full stack, Angular 2 front end full stack, Angular JS front end full stack. There's like at least 4 different ways to put Angular in there. I guess really only 2 different ways because I think in at least Stack Overflow, Angular JS or Angular and Angular.js are 2 actual different tags. Animation for game developers, I'll take that. Although I think you could probably play that off with CSS. I don't know, maybe that's one where there is a dash in it as well. Question. Do we have tags synonym normalization and play with these? No, we don't actually. On careers, they don't do that. And I don't even remember the reason. There is in search. When you're in the search product, like it's all handled on top. Where is it? So when you are right here and you start typing stuff in here, like what would be a good example? Angular actually is a good example. If I say like Angular JS, that right there is definitely going to give me all of the things. So Angular JS, here's just an Angular. Like it is actually doing it for this part, but on the entry, it doesn't do it. And I'm neither here nor there about it really, but it's all built into Elastic, and I think whatever the job query language stuff is that they have. I remember the search, it has refresh issues. Wasn't sure if it was raised higher, not sure if there are wins either. Yeah, I just don't know. I mean, as far as people typing stuff in and it wanting to change the stuff that they typed in, I feel like that is usually a problem unless it's a suggestion and they choose the suggestion. But in this case, I just don't know. It does make it a bit of a pain when we're training models though, because we have to do this step literally every single time. Like AngularJS, Angular, and Angular.js, I guarantee you only one of those is in our models. And so every time we look at stuff, we have to do conversions. Also super frustrating. Ansible. This one looks like it's very strongly in favor of DevOps, and I'm going to go ahead and believe that. But I'm going to look it up first. What is Ansible? Simple IT automation. Perhaps we could add target tag to the tags table and export it in the APIs you consume in one spot. Same thing we'd use to create search indexes. Yeah, I want to say in careers, it literally pulls directly from the Stack Overflow tag synonym table. I could be mistaken. It might have been a one-time thing. I'm not 100% on that. I really feel like it at least updates every once in a while. Maybe on a full re-indexing. I'm not sure. Oh, it hard-coded it. Okay. Yeah, no, that's one. I remember, so that table also has some weird stuff in it, by the way. Last I remember, there were ones that were like, this one leads to this one, leads to this one, leads to this one, leads to this one. So there was no just like, okay, replace whatever the synonym is with the main tag. It was definitely like you have to build the whole chain or do it repeatedly until the previous result is the same as the same result. And at one point, I want to say there was a cycle in there for one of them. I can't remember which one off the top of my head. In Mim in the app. Oh, yeah, okay. Yeah. Hey, Codephobia, what's up, man? How are you doing? It was great to see you, by the way, when out in San Diego. That was awesome. So much fun. We are currently working by hand through 800 tags. Oh, look, here we go. We get to finally redo this part. So now we want this one and this one. and this one, and this one. Okay, there we go. Look, now we got a .NET. Now we got some 3Ds. 875. All right, look, we got our dashes. We got ActionScript 3. Yeah, so that is one thing I want to be very clear. These are not comparable numbers between separate models, meaning that for game developer and front-end developer, even though these are wildly different, the thing that you're missing here is the intercept term. And the intercept term for this one might very well be like a negative 0.05, and for this one might be like a negative 0.02. So it actually does a lot more for making it a front-end job than it does for making it a game developer job. So they're not directly comparable. What I'm really doing when I'm looking down here is basically looking to see for stuff like this, where I only see it one time, then I have a very good indication that it is only useful for that one thing, and those are the ones that I'm triggering on here. Like Adobe Illustrator, which I think was already actually in there. Adobe Illustrator, and there it is. Okay. And then Agile. All right, see, this is one of those cases where like I'm just not going to pull the trigger on this. Even though it really appears that it is like a project manager thing or a product manager thing, I'm just not going to move it in there. Agile project management. Well, that one seems pretty straightforward. Product manager. Agile product management. That's product manager, Ajax, ACA, algorithm, Amazon EC2, DevOps, Redshift. I think in this case, I would put Redshift in a database administrator because it is a database. And even though it says data scientist, that just doesn't really mean anything. It's weird to put that there for a data scientist. Question. Is there info available on combinations of terms that is utilized in things like this? Is there info available on combinations of terms that is like SQL Server, perhaps? Terms tags. That's what this is effectively. I have built models right here for basically taking any set of tags and then predicting which of the dev roles it's supposed to be. But the goal that I'm actually trying to achieve right now is for a dev role, tell me which tags almost certainly land that job in that dev role. Because this is another one of those things that's going to end up being hard-coded where they're like, okay, if you see this tag, just give it this role, period. End of question. And so that's what I'm building right now, is that list. Oh, well, now we have a full stack developer in here, so now I'm not going to put it there. So EC2 is DevOps. DevOps. Ooh, don't do that. And then S3 is DevOps. Amazon S3 is DevOps. And then Amazon Web Services, I am not going to put. Data scientist for analytics we already had. Android we already put for mobile developer. Android NDK. Android Studio, both of these. Android NDK. Android Studio. Angular, no. Front end full stack, Ansible, DevOps, system administrator, Apache, system administrator. Okay. Probably gonna leave. Well, no, yeah, that's gonna be a system administrator. Google Ninja. Just stack more layers. All right, if you removed that greater than 50 filter, I think would be backend too. Probably, but I'm not super concerned about that. Ansible is DevOps. That's what you're saying. What did I put it as? System administrator? Or did I choose not to put it on either? All right, let me go back to Apache here. So Apache for system administrator is Ansible for DevOps. 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 Ansible. But everyone's opinion is different. Right. That's the thing. If it could very clearly go into two, then I probably don't want to put it there. If it is like a 90% chance of being one or the other, then I really want it to be there. Apex, API. All right, API, that's going to be backend for sure, right? API, backend. Stop it. I'm going to go with API design as backend as well. Why does it keep doing that? I'm really kind of losing my patience with it. Architecture. Nope. ARM. Embedded. Ooh, do we have an embedded? Yes, we do. ARM. Jobs only get one result total in the system correct. For example, DevOps and sysadmin. That's right. And the ones where they overlap, I would basically just ignore it. Artificial intelligence. Desktop developer. I'm going to go with a no on that. I'm going to go with a no on that. ASP.NET, MVC, Web API, augmented reality. I'll give that. I mean, there is web augmented reality, but I think it's a different tag. I think I just got your joke about architecture's useless. What is this one? Augmented reality is mobile. I'll allow it. We can fix it later. Okay. Whoa, did I just see it here? No, virtual reality. Who needs architecture? Just turn on the servers. Automation. AWS, Azure, Backbone, Backbone JS. All right, Backbone and Backbone JS for sure. Front end. Okay. Back end. Yeah, I feel pretty confident putting back end in the back end category. Okay. Background. Product manager. This is one of those ones where I want to look it up. Where is it? Background. Background. Let's go with this one. Jobs. Ah, come on. Director Technical Architecture Salesforce.com. Background. Yeah, I'm going to go with nothing on that one. Yeah, I'm going to go with nothing on that one. Big data. BDD. What is BDD? Background driven development? QA? Whatever. Alright, QA, you finally got one. Backbone driven development, big data denier. Yeah, no, literally. Wait, okay, we can figure this out, right? This is going to be on Stack Overflow. Part of me does wish occasionally that would go where I wanted it to. BDD? No, wait, no, BDD. Behavior driven development. Oh, I should have been able to guess that. Okay. Big data, Bluetooth, embedded for sure. I think we're making some progress. We're all the way up to B. What am I looking for? Embedded. There was one more right after it. Bluetooth, low energy. Sure. Bluetooth, low energy, embedded. Okay. Boost. They use Boost? I guess so. If I was going to guess anything was going to be, oh yeah, 2 p.m. call. Oh crap. Thanks. Ah, okay, so I have to run, like, all of a sudden. Holy crap, thank you so much. I'm going to drop everybody off on somebody. Give me just a moment here. I'm going to find somebody. We're going to go with... I think we're going to go with Clarkio. Clarkio is awesome. I really appreciate everybody stopping by today. I'd like to thank everybody again who gave me a follow. And I'd like to thank Nick Craver for making sure that I actually get where I'm supposed to be on time. And when you drop in on Clarkio, just say hi for me. I'm not going to be able to run in there. And hopefully I will see you all next week. I stream on Wednesdays, Thursdays, and Fridays from noon until about 2 most days or most weeks. And yeah, have a good weekend. I'll see y'all later. Now I have to wait 10 seconds after I said that, because once you click the button to go, it takes 10 seconds for it to figure it out. All right, y'all have a good one. I'll see y'all.